Hello and welcome to the Cisco Support Community. Today we present a live Cisco Support Community Expert Series webcast, and our topic today is mobile wireless and how your cellular phone serves the Internet. My name is Francine Richards, and I'm the project manager for the Cisco Support Community, and I will be moderating today's event. Our expert joining me today is Deepak Michael. Deepak is a network consulting engineer and technical lead in the AT&T mobility team at Cisco. He is an expert in EPC and wireless mobility technologies, including serving GPRS support node, gateway GPRS support node, and EPC. Deepak has 14 years of experience working with domestic and international customers, and he holds a degree in business administration from the University of Phoenix. He holds CCNP and CCIP as well as mobile specialist certifications. Welcome, Deepak.
Hey, thanks, Francine, and thanks everyone for joining.
And our expert panelists are Archit Sinya and Karit Sohilia. They will help in answering some of your technical questions during this event. Now, I'd like to briefly outline the format for today's Expert Series event. Our expert will start with a presentation on how your cellular phone serves the Internet, and that will be for the first hour of the program. And then you'll provide an answer to the question, what is predicted this year to exceed the world's population? So stay tuned for that. Then we'll dive into the live question submissions from the audience for the remainder of the event. During our live presentation, you may submit your technical questions to be answered by our presenter and the expert panelists using the Q&A box, and that's going to be on the right-hand side of your console. Now, the team of technical experts is well-versed in mobility, so please begin posting your questions now to give us the best chance of answering them. If you experience any technical issues, please post your question in the chat. We'll also be asking polling questions during the webcast, and we highly encourage you to participate by answering them. You're also going to be able to download a copy of today's PDF presentation using the link in the chat window. And also, everyone who joins today's webcast will receive 125 Cisco Preferred Access Points. So now let's get started with today's event. I'm going to start it off with a polling question for the audience. What is your level of experience with mobile wireless technology? A, I know basic Wi-Fi concepts, but no idea about mobile internet. B, I theoretically know mobile wireless, but no practical experience. C, I'm playing with it in the lab. And D, I'm running it in production. So let's give you a couple minutes there to go ahead and fill that out. Please take a moment to answer it so the expert can tailor their presentation to your needs. Also, make sure to submit your questions as we will answer them later in the webcast. And now I would like to hand the mic over to our expert, Deepak Michael.
Okay, thanks everyone for joining today's webinar. First off, I want to thank my two colleagues helping out, Kirit and Archit, with the Q&A. Please drill them with as much questions as you like. They enjoy torture. I'll go ahead and start with the webinar. Now, the goal today is for you to look at your mobile phone and kind of understand how it works. We have basic Wi-Fi, which is basically your network, and you get onto an access point and you get onto the internet, but mobile wireless is quite different. This is using technology like LTE or GPRS or UMTS getting onto the network. So my goal here is basically to give you an overview of how your phone actually gets onto the internet. And doing so, going through the agenda to aid you into that goal, we're going to do a couple of things. We're going to have an LTE overview with the real-world examples, going over control user plane, go over the LTE architecture. As well, we're going to dig into the ASR 5500, also known as the aggregation service router. This is a box which is actually used in mobile wireless networks today. As well, we're going to dig into the LTE call flows so you could actually appreciate what your mobile phone does getting you on the internet. And at the very end, there'll be a Q&A section. Okay, so LTE overview and real-world examples. Okay, so if you were to take a look at your smartphone today, and you compare it to the picture on the bottom right, you might be in awe. So going back in 1973, Martin Cooper invented the first cellular phone, weighed about 2 pounds, costing about $4,000, and only offered about 30 minutes of talk time. The phones were predominantly used by the government and some businesses too, as high cost. Today with LTE, we're looking at numerous amount of mobile devices used for machine-machine, reaching speeds in excess close to 100 megabits per second. So clearly made some great strides in the form of mobile communication. Okay, so what I'm covering today is LTE. So one thing that you will know or go through in this presentation, there's tons of acronyms. And all these acronyms have a meaning, and they're all made from a group called the 3GPP. So LTE, an acronym again for long-term evolution, is comprised of the 3GPP board, and this board is made apart from different vendors, a lot of technical engineers, different organizations, which basically make standards for how mobile communication works. This is kind of to help the end users, so if you're roaming or if you're using different vendors, say Ericsson, Cisco, Alcatel-Lucent, end of the day you could put them, mix and match together, and they should talk. As well, there's a link on the bottom, so if you did want to read through the specs and get a better understanding of what it means, it's there for you. Okay. So today mobile devices are found everywhere. They're found in places where you wouldn't really expect them as well. This is in part due to machine-to-machine devices. Today as it stands, AT&T, Verizon, easily over 300 machine-to-machine devices certified for enterprise customers. These are customers doing a lot of different things which we may take for granted. Some of these include, monitoring prescription usage. So someone could have a mobile device on a prescription cap, which tells them, hey, I took my medicine, or I didn't, or I need a refill. Some of the devices are used for location services, inventory, usage reporting, security. You can have mobile devices connected to a camera, which feed back to a central unit. And of course, streaming music to your car. So this is another new area where mobile devices will be implanted into your car. You'll be using, mobile wireless to connect to like Pandora, or hopefully not YouTube while you're driving, but things of that nature, and much more. So this is just a small glimpse. Okay. So where are we going with connect devices? So we're going many places. With machine to machine and the prevalence of mobile communication with handhelds, easily by 2020 over 50 billion. So it's really surpassing the world population as well. Okay.
Okay, so before we get back to the presentation, I would like to take a moment to ask another polling question. How familiar are you with 3GPP Release 8? A, theoretical knowledge only. B, I have minimal working experience with Release 8. And C, I have expert knowledge with one or more Release 8. So if you can go ahead and take a moment to answer that polling question. And also make sure to submit your questions, as we have a panel of experts ready to answer them at the Q&A session. And some of them will be answered by Deepak at the end. So I'll give you back the mic, Deepak.
Okay, so we'll go ahead and dig into control plane and user plane protocols. So unlike IP, which is used with source and destination routing, mobile wireless is quite different. Since your mobile phone is in fact mobile, it has to do a lot of communication to the end devices and a lot of updates, and it has to let everyone know where it's at. So it's very critical that we have messaging protocols for both control plane, which you could treat as keep alives, and user plane, which you could treat as actual user packets. So end of the day, IP is a means within the network of how they communicate with each other, meaning hop by hop, but within the IP, there's encapsulation. So we'll go into that as well. But these protocols are encapsulated, which have different information elements, which are used to basically communicate and share information amongst the network. As stated earlier, the 3GPP is that board which creates the standards to achieve both control and user plane protocols. Some common protocols that we'll go over today is GTPC, S1AP, and GTPU, which is the predominant user plane protocol. Okay, so on this slide I do have the reference of the spec here, the 23401. This is from 3GPP. This is covering control plane. Control plane is basically what it implies, is controlling. It's sending messages, heartbeats, in a form of information elements. So we have controlling on the radio access. We have controlling basically to set up activations of mobile devices, such as when you want to turn on your phone and get on the network, you send control plane messaging in a form of a create PDP context request. Controlling as well deals with path establishment and also to have support user mobility. And controlling, of course, as well supports the need of the network. So, for example, if your mobile phone needs higher QoS or bandwidth, then we need to tell the network, hey, I paid for a higher level of QoS. Please grant me this information, or please grant me these permissions. So taking a look today at some control plane. So we have 3 devices here. The first one on the far left is the UE. This is a user equipment. So this is your actual mobile phone. So this is your mobile phone or your data card. As you can see, your mobile phone has multiple layers of control plane traffic, or multiple layers that it communicates through, similar to the OSI layer. So from your mobile phone to the next hop device, which is the node B, you'll see that how it communicates. So it's almost a one-to-one pairing between the UE and the node B. Then towards the right, you have this MME. So this MME also deals with the control plane, and we're going to go into each one of these devices as well. And you can kind of see from left to right how control planes used within the network and the different associated protocols that it communicates with. Okay, now taking a look at some other devices here with control plane, now we see the MME and the S gateway, how they communicate, and as well we have S gateway to P gateway. One thing here to take note, you see the IP layer, and that's just used for how they communicate with each other. But on top of that, on the very top on the application stack, you see that the GTPC for control plane, and this is the most critical thing here, because within these messages is how we communicate amongst the network about the mobile itself. Okay, so now taking a look at the user plane, and this is, when we refer to user plane, this is actually your mobile connecting to Facebook or Yahoo or YouTube, for example. The user plane is packet user data, but what happens with your user data, it's encapsulated with something called GTPU. Basically what the GTPU, U standing for user plane, it's used for encapsulation, so it could send you amongst the network through the various entities and also provide message communication between the various boxes, hop by hop by hop. End of the day, what happens with both GTPU and GTPC is their endpoints. So you could treat GTP as a tunneling protocol. So tunnel protocols have both a source and destination, and we'll get to that a little bit later as well. Now, taking a look at the user plane for LTE, you can see here that we start here with the UE, and then we go towards the right to the PDN gateway. In this particular example, it's using a mesh of 3G and 4G. So we see some 3G devices like the BS and the BSC and the SGSN. And we also see some 4G devices like the serving gateway and the PDN gateway. But what we do see in common amongst the core network is this GTPU, and that's basically how the information gets routed hop by hop by hop through the network. And the last hop here in the network, as you can see on the bottom left, is the SGI. Let me see if I can get a pointer. So if you look here, you have this SGI. So this SGI is actually how you route out from your core network to the internet. Okay, so going back here with another example with just plain LTE, again here we see how user plane is being transposed through the network. Again, GTPU all along the way. Then it leaves the network through this SGI, which is just pure IP. So we'll see what happens here from the PDN gateway, how it takes in a packet and it allows the packet to be de-encapsulated and leaves as pure IP as well. Okay, so we kind of touched on this a little bit earlier about GTP. So GTP, end of the day, is a tunneling protocol, and it's used for encapsulation. And with anything which tunnels, it's just a means of communication between the different network elements. The way that we talk amongst each other is through tunnel endpoint IDs, also referred to as TEIDs. And the TEIDs comprise of an IP address and a UDP port number. And as well, the TEIDs have a source and destination, and these source and destinations are both control plane and user plane, which are interchanged between the different elements along the way. So, for example, if you had a MME and a S gateway, for example, these two entities would exchange control plane messaging with the TEIDs. And end of the day, what it boils down to is that each mobile context will have a TEID. So TEID is per mobile context, not per network element. All right, so you may have seen this before. So for me, this is all programmers seem to need data processors. So, but it's basically the OSI layer. And you can see here how we have encapsulation, de-encapsulation. So what's happening here is just taken from a high level. If you had a packet which came into the network, let's say coming into a S gateway, then it's going to encapsulate the message, and then it's going to de-encapsulate the message on the way out. So it's just a means of showing how that's made possible. Okay, so we did a lot talking about GTP and what it is, and this is kind of like a breakdown of what it is. We have the IP packet, which is on the outer header. We have UDP, which tells it how to route within the network. And we have the GTP, which is just the identifier. And we actually have the payload here. So here we have a control plane message with user plane message, with 2152. Okay, so here is an example of endpoints between the MME and the S gateway. So what we could see here is the GTP request message sent from the MME to the S gateway. You can see how it has its local TEID. Then we could also see here how the S gateway receives the TEID and it sends back a TEID to the MME. So it's basically a means of how they communicate with each other through these tunnels. Okay, so we talked a lot about control plane, we talked a lot about tunnels, and I did cover something about information elements. So if these information elements are basically different, I guess you could say, pieces of the puzzle when messages come across. So within a message, let's say, for example, this message here for the create request or this echo request, you can see here there's different different control plane messages. So here we have echo request, echo response, and you can kind of see how they could be either GTPC or GTPU. As well, we have different messages here for create session request response. So if you were to look into the spec, there's tons and tons and tons of messages. So it's it'll be good if you guys want to dig in a little bit deeper to look at the specs and see how this plays out with the signaling. And as well, in the very end of the presentation, I have a call flow which goes into this in detail. Okay. So if we were to look at a create session request, basically this is when your mobile phone powers up. It sends this message out to the network saying, hey, this is who I am. I need to set up a message. Some common things that if we were to look at that message on a control plane level between the MME and the S gateway, some of the things that we would see is this MZ. So this MZ is basically a defined value which is on your phone, on your SIM card. It's made up upon your mobile country code, your network code, and then it has some operator information in it as well. You have your MISDIN, which is also referred to as your phone number. It tells you your identity, your type, your ME type, and it has your RAT type, basically your radio access type, whether you're a 3G or 4G subscriber, where you are presently. So a lot of information. This is just 4 pieces of information. There's a lot more, so I just put a couple examples in here for you. Okay, so now moving forward, covering LTE architecture. So in the beginning, when I say in the beginning, this is just with voice calls, when there was no data. So the networks back then were pretty rigid and connected, didn't have IP around them, but we did have as well a lot of boxes. So it was a voice-oriented architecture, did support some SMS, and the network transport was basically through TDM. So not very exciting, no IP, things of that nature. Okay, and then at that point as well, data wasn't switched. It was switched, but it was circuit switched. So it was very different than what we have today. It was very bursty, again, over TDM. And when you wanted high speed, it was through CSD. So aggregation, multiple time slots, but very resource intensive. So you couldn't really surf the internet or do anything plausible like you can today with that. Okay, so eventually mobile phones and networks through the 3GPP, they got smarter, they got more advanced. Subscribers wanted more out of their phone. So in came GPRS, which you may hear today. It's an older technology, but still around for 3G. So with GPRS, we had the advent of the SGSN and we had the GGSN. And both of these devices, as you can see, they communicate over IP. So things are getting a little bit better. You have a colored phone now at this point, and you're able to hit some web pages or some portals, and you're doing pretty good. So what did the operators see at that point? They saw a larger demand for data, and they also saw more demand for more IP-centric network. So you could put your places in more distributed geographic locations. So in came some more advances with UMTS. The network footprint got smaller, and as well, the networks had more IP, as you could see. So, faster speeds, operators pay less for the equipment because they have to buy less of it, and you, the consumer, have higher data throughput. So, a win-win all around. With the advent of more data speeds, there were some bottlenecks within the network. So folks at 3GPP came up with some more specs. They said, hey, let's remove those devices which we don't need and we think are slowing down data throughput and let's just have the node B and the GGSIN talk together. So this is direct tunneling. Some operators use it, some don't. I guess it all depends on what they want to do. Because what happened after direct tunneling is you kind of usher into the phase of LTE, and we'll dig into that in a little bit. So end of the day, what happened was that the operators saw a growing impact for IP transport. So out went the old with the 2G and 2.5G architecture, and what came in was a less rigid distributed approach for data networking. So with an all IP network, your boxes could be in different places. You're not solely limited on physical storage of space. So it was more flexibility, and it was more intelligent as well with the network. So again, on the left, you kind of have a UMTS network. You can see how it's kind of large and hierarchical. On the right, you have the new network, the LTE. And here we're kind of focusing in on the EPC, the P gateway, serving gateway, and we're also including the MME in that as well for the whole core. And as you can see here, we're talking IP, so it's very flexible here. You can have networks in different places, and just have routers route across where you need to point these boxes. Okay, so we talked a lot about LTE and how it's great and how it's the new thing. So, what is it? So, LTE today on your mobile devices is basically high-speed data. So you're getting speeds up to or close to 100 megabits per second, depending upon where you are and things of that nature. But it's basically very high speed. I mean, my own personal device, I get better speeds on my phone than I do at my home internet. So it's very powerful. And how is this made possible? Well, it's made possible by great advancements in the radio access network. So on the bottom here, you see an So here, what you see here with the advancements, you see the node B communicating with the MME. So it has a smaller footprint, and basically you're sharing more resources and offloading resources to other network elements. So instead of one element doing all the functions of radio access, it's being split amongst the node B and the MME. And as we were saying earlier, both of these devices, and actually all the devices, communicate through different protocols and different interfaces. So one of the interfaces here from the node B to the MME is called the S1 interface, or the S1 MME. And then again, we have different interfaces between the serving gateway and the actual E node B, called the S1U. So again, more acronyms and more references, but the specs will cover that, and we have some good slides that do that as well. Okay, so today, if you were to look at the architecture of the LTE network, this is kind of what you would see. There might be some things missing depending on what the operator is and how far along they are with LTE, but end of the day, this is kind of like the basics. As you can see here, we didn't leave out your mobile device. So your mobile device is there, and that's the reason why all this is being built. But if you want to take a more high-level look, we have what we call the Evolved Packet Core, and that's highlighted here. As well, we have the different access technologies. So we covered the EU-TRAN, which is for LTE, the GE-RAN for 2G, and the U-TRAN, which is for UMTS. So just more breakdown here of the different technologies. Okay, so as well, we have what we call a non-3GPP access. So so basically here, the non-3GPP access is things which the operator doesn't consider part of their normal network. So this could be something which is roaming from CDMA, or in this example with EPDG, which requires some IPsec for untrusted. So basically, this non-3GPP access is I wouldn't say it's new, but it's something where I think operators are getting to, but not there yet. So the basics are still here within your Evolved Packet Core and your LTE. All right, so we talked about some of these devices before, but I would like to get into them individually. So here you have your Node B, and your Node B, end of the day, connected to towers that you see along the road or on buildings is how your mobile phone communicates to the Node B. So the Node B talks to the mobile device, the UE or user equipment, through what we call the UU interface, and it handles the radio resource management, and it also is the bypass for the rest of the network. So very important device. Without the Node B, you wouldn't be talking to the network, and your phone wouldn't have any service. And as well, it exchanges user plane and control plane. So it's doing a lot of information. Okay, as well we have this MME, the Mobility Management Entity. So it handles the signaling traffic, no user plane, just signaling control plane. It talks to this HSS, which you see hiding back over here. This is basically a database which stores your user information. So it'll have like your, are you allowed to get into the network? Are you not allowed? It'll have your access point information. It'll have your QoS information. A lot of subscriber-related data would be in the HSS. So the MME would talk to the HSS to validate subscription. Okay. As well, the MME, going back here, interacts with the Node B and with the serving gateway. So it's a means of communication between Node B and the S gateway. Okay, so going now again to the S gateway. So it's the anchor for the data. So S gateway talks to the eNode B through S1U. This is for GTPU, and S11 for GTPC. And it's basically the mobile anchor. So your mobile phone geographically will talk to the S gateway. It'll send updates to the S gateway about its location, what you're doing. Do you want to detach from the network, attach to the network, things of that nature. As well, we have the PDN gateway. This is an anchor point for IP. So the PDN gateway assigns IP addresses to the mobile, and it communicates to the outside world. So from the PDN gateway, you'll talk to the internet, for example. Okay, and as well, you have a policy-aware server, the PCRF. So the PCRF does a lot of different functions. It could also as well validate subscription from a mobile. It could relay information to things like the balance manager to see if you have enough quota. For example, if you were prepaid. It could also provide QoS information to the gateway to enhance your QoS or to make your QoS smaller. Okay, so going back here, looking at the non-3GPP, so this could be some fixed wireless like Wi-Fi, for example. And where it says trusted and non-trusted, so it's really up to the operator to dictate what's trusted and non-trusted. What is true is that for untrusted, it has to use this EPDG for IPsec. Okay, so end of the day, what happens here, as you can see in this red line, is that you're on a 4G network, for example, your mobile device will talk with the Node B serving gateway, PDN gateway, and go out to the operator's IP service. So this is basically the internet. So this is all user plane as well. Okay. And just some more examples how the other UEs communicate. So you can have another UE going directly through the PDN, and then you have another one going through the EPDG.
Okay, and we're going to ask another polling question at this time. How familiar are you with EPC? A, theoretical knowledge only. B, I have minimal hands-on working with EPC. C, I have expert knowledge pertaining to EPC And D, I work with boxes that communicate with EPC. So go ahead and take a moment to fill that out. And keep submitting your questions so that we will answer them a little bit later in the Q&A. So I'll hand it back over to you, Deepak.
Okay, thanks. Okay, so we talked about the theory of control plane, user plane, talked about tunnels, messages, we talked about the different network elements, but now we're going to focus on one network element in particular. This is a Cisco 5500. Basically, what we call the ASR 5500. This device is a mobile wireless device. So this device will work as a GGSN, S gateway, and a P gateway. So in the slides previously, how we indicated the network elements, this device would take the place of at least two of them. Okay. So, just let me go to the next slide. Okay, so the ASR is not a new device. It's been around since 2002. So you can see the different hierarchy, or the different evolution, rather, of the ASR. We do have some numbers here as well about sessions and throughput as well. So these are, relatively high horsepower, very intense devices that handle the amount of traffic going in and out of these data centers for mobile wireless content. So today, if you were to look at an ASR 5500, you have your basic power supplies, you have different fans for ingress and egress coming in from the front, leaving out from the back, and you also have different cards. So we have management cards, slots 5 and 6, which are also used for I/O. So there's 10 gig interfaces on these. We also have the DPC cards, or the data processing cards. We also have fabric and storage cards to talk between the cards and used for storage of, let's say, CDRs, or just basic data structures, software, for example. We also have some system status cards, which monitors the health of the box and can also have the ability to send an audible alarm. So again, if we want to take another look into the different card architecture, we have this management card. We call it an MIO card. Again, the DPC card. Okay, and the MIO and DPC cards are considered rear cards. Then we have these fabric switch cards and the system status cards, which are considered front cards. So a lot of cards, a lot of things going on. Kind of giving you a breakout of these. So the MIO card, like we said, is an input-output card. It also communicates with the other cards for ingress and egress traffic. The DPC card, the data processing card, is just like the name implies. It deals with the user context being set up. Also deals with the user plane as well. Okay, and the fabric card deals with the fabric storage. It also has RAID as well. Okay, and the system status card monitors the system and the overall health of the network. So alarms, power filters, temperature, air control is all handled with this card. Okay, so the box alone as well encompasses a Star OS operating system. It's based on the Linux kernel. As indicated, it's the surrounding kernel is Star OS. We log in, or we enter commands through CLI, so you can use Telnet or SSH to get into the box, or console if you wish. And just digging into the operating system a little bit more, it's a model of distributed processing, so we could have your call, say your context could be on split between different DPCs, as well. One software loads all the cards as well, so it's one image. And end of the day, the software architecture is based on redundancy. So with mobile wireless networks, I mean, there are SLAs for uptime and things of that nature. So redundancy is built into the software and for the hardware as well. So just giving you an overview of kind of how it looks from a software perspective. So if you were to look at an ASR 5500, you have your primary, secondary MIO cards. You can see the different processes running there, as well with the control cards or the DPC cards. You can see all the different processes there. So these are replicated amongst each other as well for redundancy. Okay. So again, the reason why the software and the hardware is built this way is for redundancy, scalability, and robust call processing, distributed processing amongst different tasks, and everything is invisible to the user. So when you get onto the internet, you have no clue what's going on behind the scenes. There's a lot, mind you, but there's no evidence of that. Okay. So again, building the software this way for the operator, what it does, it creates an environment where you could remove cards if you had to. So if one card was bad or something happened to a card, you could remove it during the day if you would, or, and change it out. So this kind of deters from customer impact. As well, there's multiple context support, and we'll get into that. So if you're familiar with a VRF or a virtual route forwarding, context is somewhat similar along those lines. Okay. And it does leverage third-party software components, which is the Linux operating system. Okay, so how does all this stuff work within a ASR? So it works through context. So if you look at an ASR today, you have different contexts, and these contexts have different functions within the box. So if you have you could have OEM, how you log into the box. You could have a SAE gateway context, and this is kind of how we showed earlier, how you can see here it says UE, eNode B, and MME. So you can see how we communicate through the context through this particular SAE gateway. As well, we have a context called SGI, and this is how we get out to the internet. And as well with mobile wireless boxes, especially with the gateway, we do deal with the PCRF and with billing. So we have a context as well for this. Okay. As well, there's need for lawful interception, which is through the gateway as well. So we have a separate context for LI, or lawful intercept. And as well, if you would like to have more redundancy than just software and hardware redundancy, you could have two ASRs, and this is achieved by SRP. So this protocol would run between the two ASRs, and basically if one whole box were to go down, then you have another box to pick up where it left off. Okay, so if you were to look at the services, and the big one is the SAE Gateway service, because this service talks to the outside world, meaning to the MME, it talks to the eNode B, which then, downstream or upstream, rather, it talks to your mobile phone. So if you look at that today, what you could have in your architecture is, it could be something as follows. So you could have possibly two VLANs, going out to two different routers, for example, for redundancy. These could be running equal cost multipath. And as well, you want to include different services. So like we said earlier, you have like a GGSN, a S gateway, a P gateway. Well, we could have one box which could do all of these things. And the way that we do that is through a service. So here we have a GGSN service, which will tie into a loopback interface. So you could see this /32. And this is basically how the outside or the next hop device will communicate with it. And these are linked up together. So here you can see the GGSN will talk to the SGSN. As well, we may want to have a a user plane service. Here we call it a P gateway data service. And you can see how these two could talk with each other and, again, talk to the outside world, and they too will talk as well. So you can see how these services tie into each other, how you will have a eGTP service for P gateway, and you would see the service as well, how it's associated. So all these services tie into each other, and they communicate through one common loopback to talk to the network entities. So take, for example, here, if you have an S gateway, and you want to talk to control plane to the MME and user plane to a node B, you would add all the applicable services. You will have a common loopback IP. And you would also have routing within the box, because as we saw earlier in the slides, you have a S gateway and a P gateway, which appear to be different boxes, but here it's all combined under the SA gateway context. So this one box could do P gateway services, S gateway services, and GDSN services, and they all talk internally. As well, for user plane, going back to the mobile, we would have a different service for GTPU service for the S gateway. It too will have its own loopback IP, and it too will talk to the node B. So you could kind of see how, within a box there is a lot of different things going on, and a lot of well, I wouldn't say a lot of configuration, but there's a lot of things going on which are transparent, which is good. Okay, so if you wanted to take a sample, if you want to look at a sample configuration of a service, here showing a CLI example of a GGSN service out of a box. You can see here how we have a GGSN service. We have different data fill for timeouts, retransmission. We tell it to use different types of variables for the public LAN mobile network. And we have associations. And we also tell it how to bind to an address. So we saw this earlier, this address, this is actually the loopback IP. Right? So here's a GGSN service, and now we're wrapping into a P gateway service as well. And then we move into a S gateway service. So a lot of different services here. And we have the bindings, right? So, and as you can see here, there's some for IPv4 and with IPv6 as well. All right, so just looking at more services, so this is just more data fill. So if you look at this P gateway control service, there's different parameters we could define here under the service. Okay, so with your mobile phone, you have to have an IP address, and the way that you obtain an IP address is from the P gateway. So the P gateway could have a IP pool, and as you can see here, it's just an internal pool. And this internal pool eventually along the way will hit a NAT firewall and get translated to a publicly routable. But for all intents and purposes, this internal pool could be reused, and it's assigned to the mobile device. Okay, and how does the pool and how does the mobile device know to communicate with the gateway? Well, on your phone, as we indicated earlier, your actual subscription on your phone is mapped into an APN, and an APN is essentially just a name. It's an access point name. So those machine-to-machine devices, they could be ranging from like Barnes & Noble, FedEx, Coca-Cola, for example. These are just names, and you could treat them as a service or a way to function with the network. So take, for example, your phone today may have an APN, or it does have an APN. And that APN tells the network how to reach a particular gateway. And within the APN itself, and here I use an example called Cisco Static, it just tells you a couple things, right? well, not a couple, it tells you a lot of things. It tells you, hey, this is the charging server. I need to communicate. It needs to tell you the primary and secondary DNS. So on your mobile device today, if you were to look at, the DNS that you obtain, it's actually from this APN configuration. It also has some timeout entities, and it also points to some ECS, which is basically local policy on how to route a mobile. And as well, it gives you like the context name, so it tells you what context you came from, or what context the config's in. Okay, so at the end of the day, what the ASR 5500 does, allows you to do, meaning the operator, it allows one box with multiple services. So the ASR could act as a S gateway, a P gateway, and as a GGSN. So it's doing a lot of different functionalities within one box. Okay, so if you look at a call flow of how the flow of your mobile device comes into a ASR today, your call will come in from the radio side, enter into ASR through this SAE gateway. It will then hit a APN, and then from the APN it'll map you to an SGI, which is basically an internet content, and it'll send you out to the internet. So apart from that, it's doing other functions internal to the box, like it could go and check with the PCRF to check and see if you need to top up, if you're running low on your volume. So if you have like a subscription of 50 megs and you're at 30 megs, the PCRF working with the balance manager would update the gateway with that information. Okay, so lastly, just putting it all together, the control plane, the user plane, the different network elements, and going through the spec, I would like to go over the call flow for LTE. So this is kind of daunting, but it all kind of makes sense when you look at the high picture. So if you see here your mobile device on the far left, here you see the user equipment. Take, for example, this mobile is powering on. You can see that it sends an attached request. With this attached request, basically, the big takeaway here is your MZ, which is embedded in your little SIM card in your phone, and your access point name. So the APN is very important for the main reason that it tells the network how to reach the gateway. There's a lot of other pieces of information within that UE as well, used for authentication, things of that nature as well. But basically, your phone powers up, you send the attached request to the node B. The node B will send that to the MME, which is the device right next to it. The node B will perform the node B will reach the MME through a DNS lookup. So one thing which is not shown here is, let me see if I can get my pointer. Can't get it to. So basically here on. So here you have a DNS lookup from the node B to the MME. And why do we use DNS? Well, DNS will basically tell you when you power up that everyone has a geographic location. So based on your location, the node B will query the DNS to find the closest MME. So it's based on topology. Once it receives this information, then it'll send a request to the MME. And you see DNS used quite a bit here in the mobile wireless world. So this is one form of DNS. You could call it a node B DNS, for example. As well, we do identity request and response, and this is basically trying to see if the mobile is known to the network or not known. And as we said earlier, there's some authentication which happens on the network. So your mobile device here will talk through the MME to the HSS to obtain information, subscription information. Okay, as well, the MME would download the data profile from the HSS. This will tell the MME that, hey, are you allowed on the network? What APN are you allowed to use? And your status. Okay, as well, the MME will then do a create session request message. So this is, again, all control plane, which we were talking about earlier. So here, through this S11 interface, the MME will send a create session request to the S gateway, and this too is based on DNS. So the MME will look at the APN, which it obtained from the mobile phone, and say, okay, you're using, I don't know, the Cisco APN, and they'll say, okay, Cisco APN, I need, whenever that APN is used for this subscriber, I'm going to point you to this particular gateway. So it's basically telling it, hey, I need to find the gateway through this APN, which is being resolved by DNS. Okay, so in that create session request message, there's a lot of information what goes in there. The APN DNS tells the MME the S gateway IP to use, the P gateway IP address to use. Also includes the mobile's IMSI, the MISDN, the APN, the ULI, which is a user location, and the RAT type. So those are just some of the information elements. There's a lot more. Okay, that request is then obtained by the S gateway and forwarded to the P gateway with basically the same information. But along the way, as we indicated, there's GTP. So all these messages are being encapsulated with GTP, and there's tunnels that are being built here. So the tunnel IDs are being sent between the S gateway and the P gateway, which allows it to send the return response back. So it knows how to do the mapping. Okay, so once that create session request comes into the P gateway, the P gateway may have a PCEF functionality, which will talk to the PCRF through what we call the GX interface. So it could request additional data from the PCRF, like it could ask for updated QoS, it could ask for subscription information, and policies as well. So once we get that information back from the PCRF, the P gateway will send a response to the S gateway. And the P gateway, the big takeaway here, the P gateway will do two things. The main thing is it'll say, okay, that user's allowed on the network, and it also give you your mobile IP. So if you remember a couple of slides ago, we showed the mobile IP pool. So from the mobile IP pool, the P gateway obtains an IP address from there, and it sends it along the way to the S gateway in this create session response message. That response message is then sent from the S gateway to the MME. MME forwards it over to the node B. The node B takes a look at it, and it sets up some RRC connections. So here the node B needs to, and the UE, they need to set up radio access bearers and IDs amongst each other, and it needs to know what QoS it's using. So a lot of information goes on here on the RRC. There's some additional information here that for the between the node B and the MME, sends the initial context response message, which basically is giving you sharing TIDs once again. And here we just send a direct transfer from the mobile device to the node B, which is basically encompassing the attach complete. So the attach complete sent to the MME, and that way it knows that all the control planes been set up, and it received what it has to allow that mobile onto the network. But with any mobile device, if you turn on your phone today, there's other applications in the background that want to get to the internet. So those devices, while you're powering up your phone, are trying to get to the internet at the same time. So once you have your IP address, those devices have the conduit, meaning the IP address, to try reaching the internet. So you can see here that there's a first uplink packet. So the mobile device sends the first uplink packet out to the internet. The internet, from from the P gateway here, it could hit a firewall and become a more publicly routable IP, and then it will go out to the internet, Facebook, Google, Yahoo, Cisco.com, what have you, and it will come back around. The firewall will know how to map you back to an internal IP, and then from there onwards, it will buffer the packet. Now, the reason why it buffers this packet here on the P gateway is that we're waiting for this modified bearer request message from the S gateway. And what's happening here is that the MME is telling the S gateway, hey, if you want to communicate to the node B, use this IP address to communicate with the node B for data, for S1U. So upon delivery of this modified bearer request, we're going to buffer the packet. And we acknowledge the modified bearer within the S gateway, P gateway, and the PCRF, just in case if we have to update your QoS or if we have to do something special with the call. Once all that's done or completed, that buffered packet is going to be sent down to the mobile device. So that pretty much covers it on how your mobile communicates to the internet. So, just from one mobile device and where it attaches to where the first downlink packet occurs, there's a lot of different messaging which occurs, which is very transparent to the network user, which is good news, because if it wasn't, then there would be trouble. Okay, so that concludes the slides.
Okay, thank you, Deepak. Great presentation. Also, I want to thank everyone for participating in the event polling. And before we get started with the Q&A session, I want to play a quick game and answer this trivia question. And we'll show the correct answer at the end of this session today. So let's see how many of you can get the correct response on this. What is predicted this year to exceed the world's population? Is it A, smartphones will outnumber humans this year? B, mobile internet devices will outnumber humans this year, or C, tablets will outnumber humans this year? So just take a moment to answer that. Let's see if you can get it right. And now we're going to answer some of the questions the viewers have submitted today. By the way, if you can't stay with us for the Q&A, please be sure to click on the evaluation link that will pop up once you close your browser to let us know how the session met your business needs and expectations. So let's start with the Q&A. And we have a question on what spec is used for GSM?
Yeah, so there's multiple specs that are used for GSM. So in the slide deck, we offered a link with the different releases. So there's multiple specs for the different interfaces. So if you look, like when we went through the call flow, there's GTPC, GTPU, there's DX, GX rather. All these different interfaces have different specs. So there's a lot. So we do have a reference in the back of the slide deck, as well. These specs also relate to releases. So I went over release 8, which is LTE. But there's also enhancement with release 9 and release 10. So it really depends what you're looking for. But it's all within the 3gpp.org.
Okay, and we have another question. As mobility continues to grow in organizations, BYOD, how can or does security integrate with the continued need for robust solutions without compromising data confidentiality?
Yeah, so that's a good question. So in data networks today, especially with enterprise subscribers, the way that's handled is enterprise subscribers could actually buy space, if you would, on a GGSN. So customers like Verizon, AT&T, you could have like custom APNs. Take, for example, I don't know, throw it out there like Cisco, for example, Coca-Cola, what have you. You could have your own APN built on a GGSN, and whenever that mobile device attaches to the network, it'll use that APN, for example, Cisco, and once it hits the gateway, it'll say, okay, you're coming into my network with the Cisco APN, I have my own IP pool for you, or I have my own MPLS network for you, or I have my own IPsec tunnel for you. So there's things on the back end where subscribers or corporations could buy APNs or usage of ASRs, which facilitate that.
Okay, thank you. I wanted to mention, too, we have some questions about certification and what study guides to use and so forth. That is a better question for the Cisco Learning Network. CLN is our sister site, and you can reach them from the Cisco.com page, and they have all the information on certifications and everything. So do check them out if you have certification questions. Again, that's the Cisco Learning Network. Now, another question we have is, what spec is used for CDMA?
Yeah, so for CDMA, they use 3GPP2. It's a different spec.
Okay. And another question here is, what is a bearer?
Yeah, a bearer is, you could think of it as a conduit to communicate between devices. So a bearer essentially, on the radio side, you have a radio access bearer, which will say, hey, between two devices, this is the QoS, the IP address, and the precedence, how they communicate with each other. So it's comprised of different things, but at the end of the day, it's a conduit on how that mobile device communicates with the network.
Okay, thank you. And there's a question here is, what is the port for GTPC?
Yeah, so GTPC, as we were covering it through the slides, is port 2123.
Okay. And one other question here, what is a TEID? Yeah,
the TEID is, I just want to clarify as well, so for the earlier question, GTPC also uses 2152 for GTP version 2, which is used for LTE, so it's a different variant of the GTP spec. And for the next question, for what is the TEID, the tunnel endpoint ID is basically the means how the boxes establish point-to-point connections for control and user plane for a single mobile.
Okay, thank you. And there's another question here on the difference between primary and secondary PDP.
Yeah, so primary PDP could be like your like if you have a default bearer, then you have a dedicated bearer. You could have primary and secondary PDPs. Or if you have, for example, a IPv4 and IPv6 PDP as well.
Okay, and another question in regards to security solutions. What is the continued evolvement as more and more software-based technologies are being compromised?
So so for security, the involvement is, as it indicated earlier, was having it's a dual approach. So the actual mobile device itself has security algorithms based within it. You can as well use your own, let's say, end-to-end security. So if you had to use like a VPN tunnel, things of that nature from your laptop, you can do that, firewall permitting. As well, the other option is if you wanted total security of your end-to-end flow, you could have a commercial APN built within the ASR, or the gateway rather, and you could actually further segment it through a content or a VRF. So you're actually isolating your network amongst the other networks within the box.
Okay, and another question here is, what is an NSAPI?
Yeah, the NSAPI is basically how the mobile device communicates to the network. So these are network service application points within the network. So the NSAPIs just tell the network how to communicate.
Okay, and there's a question too on APN. What is APN?
Sure, yeah. So APN's pretty important. So APN's an access point name. It could be, company specific. It could be service specific. So the access point name basically is on your mobile device today. So your mobile device may have an APN which maps it to a service. So that APN, once it's on your phone, when you power it on, that APN will essentially tell the network how you should be handled. So depending upon your APN, it'll tell you what gateway to be on, and it can, in some instances, tell you, what mobile pools to be used for like corporate customers. So corporate customers, for example, will have their own specific APNs, which may map to their own VRFs, their own IP pools, and to their own VPN tunnels, for example.
And you touched on this, but can you elaborate a little bit on the benefit of LTE?
Yeah, sure. So LTE is really paving the way for high-speed data. So from an operator perspective, it's making the network smaller, having less devices to control the mobile. But from an end user perspective, which I think is our greatest concern, or what we look forward to, is higher data. So with LTE, you could have streaming audio, video, voice conferencing, higher bandwidth than you normally would at home. So LTE is really opening a lot of doors for folks to have high-speed bandwidth on their mobile device, and then, for example, using hotspots within their own home or within their small network to branch or daisy chain from. So LTE is just basically high data, low latency.
Okay, thank you very much. I think that answered all of our questions. So that's going to conclude the Q&A portion of the event. We want you to fill out the evaluation survey, and everybody who does that will be entered into a raffle to win a $50 Amazon gift card. And you can access the survey at the end of the webcast or at the link that's going to be posted in the chat window. If you have not explored the Cisco support community, take a moment to check out this excellent resource at https://supportforums.cisco.com. We will be posting the recording and the questions and answers from this webcast in the community at the link provided in the chat within about 5 business days. We're also going to have the slides posted on the community, and that link is posted in the chat window. Deepak will be also answering your questions in an Ask the Expert event, which will be posted shortly after the event today, and you can access it at the link there. If you have additional questions, this is a good time to ask them to Deepak, and he will be answering those from March 5th to March 15th. We also have some different webcasts and events coming up. Our next Expert Series webcast is in English, and it's Configure and Troubleshoot Wired and Wireless Networks Using Cisco Prime Infrastructure. That's with Teja Shah, and you can register at the link there, http://tinyurl.com/CSC web events. And that's going to be on April 2nd, and it's 8 a.m. Pacific time, 11 a.m. in New York, and 5 p.m. in Paris. We also have webcast events in local languages, so if you speak any of these languages, you can attend those. Upcoming live webcast in Spanish on March 12th, and that's going to be on ASA, 8X, VPN access, and any Connect VPN client using self-signed certified configuration and troubleshooting. There's also one coming up in our ever-growing Russian community, upcoming live webcast, and that's going to be in Russian March 19th. And its virtual switching system and its implementation on Cisco Catalyst 4500 and 6500 platforms. We also have an upcoming live webcast in Portuguese on the 16th of April, and that's Multicast VPN Fundamentals, Configuration, and Troubleshooting. And you can register for those local language webcast events at the following URL. We also have some Ask the Expert events that are now running in English. Our first one is Securing Today's Collaboration Environments, and that's with Akil Bill and Jason Burns. And you can learn and ask questions about how to apply security to collaboration platforms and environments. And that's going to end on March 8th. The next one is a topic, Deploying, Configuring, and Troubleshooting Cisco WebEx Meeting Server. And that you can ask questions regarding deployment, configuration, and troubleshooting the Cisco WebEx Meeting Server, and that ends on March 8th. And you can join the discussion for those Ask the Expert events at the link shown in the slide. We have communities in other languages. If you speak Spanish, Portuguese, Japanese, Polish, or Russian, we invite you to ask your questions and collaborate in your own language. And you can either go to the links on this slide or go to our home page and go to the different communities up in the upper right-hand corner. We invite you also to actively collaborate in the Cisco support community and our social media. And you can get to any of those links from the following page, https://supportforums.cisco.com. And we're active on Facebook, Twitter, YouTube, Google+, LinkedIn, and you can also subscribe to our newsletter. We also have technical mobile apps that are downloadable from iTunes and the Android Play Store. And we currently have a mobile challenge contest going on. So if you load down those apps, we have questions to test your technical knowledge, and you can win prizes. And that contest is running every 2 weeks. They'll post a new question, and that contest is running through July. Now, the trivia answer, what is predicted this year to exceed the world's population? There was 3 choices there, and the answer is B. Mobile Internet devices will outnumber humans this year. A report from Cisco said the number of smartphones, tablets, laptops, and Internet-capable phones will outnumber humans. Mobile video already makes up more than half of the data transmitted worldwide, and it will make up 2/3 of it in 2017. And smartphones make up 92% of global mobile data traffic, despite only 18% of the handsets used globally. And the amount of Internet-connected devices will exceed 7 billion, which is the world's current population. So before signing off, please take a few minutes to complete your evaluation of today's session, and this will help us address your business needs and interests in the future. And I also want to thank our expert, Deepak Michael, for sharing his expertise with us today. I also want to thank our experts, Archit Sinya and Karit Sohilia, for answering some of the technical questions. And I want to thank everybody for attending. And this concludes our session for today. Have a great day.